So this week's tutorial will be on debugging. So why debugging matters? Because there will be bugs and you will need to fix them. Debugging and testing usually takes at least 50% of software development time, and even more for any other complex systems, like hardware, like electronics. It is a learned skill. You can learn to debug effectively, and you will eventually develop the skill to be more and more experienced. The system is not magic, meaning that you can understand it. And when you understand it, you will be able to debug, to find bugs in it. It is a deeply rewarding experience if you can find a bug and understand it and fix it. So today I'm going to introduce the models, algos, and methods on debugging. And then I will show you a demo on debugging a bug in the function that we wrote last time. And we will end with a team debugging activity where you will need to work in teams and find out a bug in a given code. So the infection model, software systems are causal. Has anyone seen this word before? Causal. Yep. Yes. A causal system means that everything in the time is dependent on everything before it. It's dependent on something before it. So the state of the system at some time is dependent on the state of the system at the previous time. This is called causal. And so are many other types of systems. A faulty operation causes an infection in a state of the system at some point, but you can't see it right at the point. The infection will spread through the program state, and it will cause an observable failure sometime after it, like a crash, or it's printing out wrong value, or anything that's observable to you. So for example, you have your states and your program variables here, and there's some faulty code with some bug, and you will result in an infected state, but you won't be able to see the infection. You won't be able to see anything going wrong at this point. Then as the program continues to execute, this infection will spread and will finally result in something observable that's available for you to see. So debugging will means that you have this observed failure and you need to find the faulty code from up here. The Wolf-Fence algorithm is just an algorithm to find bugs. Say you want to find a wolf in Alaska, which is this huge state here. How do you find it? A way is to put on fence. You put on a fence in the middle of your search space, and you eliminate half one side of the fence. once you are sure that it's not on this side. Then you put on another one and continue eliminating until you eliminate everything and you have the last small fraction of the search space that you are sure that the wolf is in. And this is the similar approach for finding the root cause of a bug. The potential set of root causes is huge. It's the entire program. But to eliminate possible causes from this huge set of root causes with the least effort is to put on fences. Say you see an observed failure at this time in time. You put on a fence in the time of program as execution, and you are sure that the program state before the time is completely correct. So the failure has to occur after this time. So you eliminate everything before this time. Then put on a fence again and start eliminating. In the end, you are left with this small search space with this failure, this state, this variable coming depending on these two variables in time. And you have this variable depending on these two variables. But these two variables are verified to be correct. So then you examine the dependent variables and you see that this variable is correct. So this variable has to be incorrect. So this means that something's wrong when going from these two variables to this variable, and you will identify the root cause from there. So this is just a technique to eliminate the set of root cause that's definitely not causing this bug. So the detect or scientific method for debugging is then in a loop. You first observe by inspecting the program state, by viewing your outputs, your error messages, and inspecting the variables with the debugger. Then you start your hypothesis of where you think that the bug should be originated from. When you develop hypothesis, you predict what will happen if your hypothesis is true. Like the variable will exceed the size at some point, size of a vector at some point. Then you experiment with a controlled experiment by rerunning identical scenario in the debugger, and you observe and you validate the hypothesis if it's correct and invalidate it if it's not. Then you can eliminate that. Then you start your cycle again. Next, I will be showing a debugging demo on the function that we wrote in our last tutorial, which is the find three segments of intersection. So in this function, we are having the intersection ID, and we are returning in the vector the three segment IDs connected to it. So we have this global variable, intersection three segments, which is a nested vector containing the vector of three segments at each in the outer vector. And this is the code that we are going to look at. So the load intersection 3 segments is called in the load map function, and it loads in the global variable that we have. And the actual function itself will just return the element in that nested vector. Okay. Any questions to this point? Let's go to the so this is my repo. It has the same thing as your repo from Austin 1. I will be opening it in VS Code. So in here, I have the source file m1.cpp and the main source file main.cpp. And the tests contains empty tests. So the first thing to do is to do a make. And then do the EC Neutral 97 exercise 1. And let's see what happens. So you will see all of the tests running. And if we look at the m1.cpp, we'll see that the load intersection 3 segments is called in the load map. Find 3 segments of intersection returns this, which is the same as I just showed. And everything else is empty, returning empty vectors or zeros or false. So we see that the tests have run and everything's failing except for load map and some of the Valgrind tests. So now I don't want to run the other tests because I haven't implemented them. So I will be modifying the command to only run the intersection test. I will modify this to run the functionality intersection test using this command. And this will just run this test. And within the intersection test, there are 3 tests, testing 3 functions. So the first one is, the last one is find angle between 3 segments, which is not implemented, so we are not looking at it. Directly connected, we have not implemented. So the first one is here. So the error we are trying to look at is here. Failure in intersections 3 segments on handled exception test crashed. So this error message is not telling us anything. It just says it crashed at some point. Okay, anyone knows what to do next? Because our test crashed, then we want to find out where does it crash. So what should we do next? Yeah. Yeah, let's change the configuration to debug check. Configuration debug check. And launch target make clean, just to make sure. And let's run the tester again. It's doing more. And stopped right at the test. So it says it's building and running the test, and the build passed means that there are nothing wrong in compiling. And running it, it shows there's something wrong in vector. And it says there's an error. Attempt to subscript container with out of bounds index 1, but container only holds one element. This means that we are trying to access some vector with one element and index 1. So we are failing. So this is why we crashed. Okay, now we know that we are trying to access a vector at some point out of bounds. But this doesn't tell us more. What should we do next? By the way, you answer the question so you can get a chocolate bar if you want. And but we don't know where it crashed, right? Let's try this command. Debug tester. So remember this command, EC297 exercise, debug tester, and the test name. Let's see what it gives us. So when you run this, it will give you the messages. Recompile the project in your IDE using unit test configurations. To debug, open the debugger in your IDE. To run Valgrind, use the following command. Let's change the configuration to unit test release, and let's see what will happen. And because we changed the configuration to unit test release, we are going to change the launch target to build release and the test target. Let's build clean and run it. You'll see that the test has been run. And if you go to the test folder, you will see that there's one file being added here called the M1 function intersection Toronto, Canada public. So this is the actual public test file that the auto tester is running. And you are able to check it out and you will be able to modify it. And because we don't want the other tests to overflow the terminal, we can just delete those. So we want to find 3 segments of intersection tests, but we can remove the other 2, like this. Save it, and I removed the other 2 tests. Yes, because we are only testing the find 3 segments of intersection. And the functionality test of the intersection test is testing all the other two, which are not implemented. So we want to eliminate that. Let's run this. Not at the end. Okay, yeah. This is the output that it gave me. So in this case, it's only running one test because I removed the other two. And this will be the same message that you will see when you run the actual tester. Let's change this to debug check and see. Just be careful that you will also need to change the launch target to debug check. We build clean. And we run. And you will see the same output from the tester. This is just showing you that you can do it. And let's change back to debug mode and let's open the debugger. Build clean. And open the debugger. Just notice that I have not set any breakpoints in the program, but it's still executed and it stopped at the place where the program crashed. And this is in the new allocator.h. It's part of the C library, the C++ library. And when you look at the call stack, these ones are just files in the library. So you want to go to the actual code where you had, which is here. And you will see that this is a line in the load intersection street segments function. And you are trying to push back something into something. And when you look at the index, it says 1. Okay. Is any of my operations not clear to anyone? Let me remove the expressions. So in this case, I'm trying to push back an ID into intersection 3 segments, which is the global variable that we have. Index 1. And it failed. It says that from a previous output, it says we are pushing into, we're trying to access a vector using the square bracket operator with index 1, which is index 1 here. Everyone can see the index 1, right? And the vector only has size 1. This is from the previous message from the debug check. So let's check the size of this vector. By adding in a watch dot size. Let's check what this value is. 1. This means that for some reason, this global vector, this global variable, which is a nested vector, the outer vector only has size 1. for some reason. And why is that? Let's set a breakpoint at the beginning of this function and let's restart the debugger. And let's step through. So in this case, the size is 0. And it becomes 1 here. Because we're pushing back an empty vector into the global vector, the global variable. And we enter the for loop, where intersection is 0 right now because it's the first iteration of the for loop. Then the first iteration ended smoothly. And let's continue. It crashed here. And the site stayed at 1. Anyone has an idea why? Let's do it again. So this is a vector of vector. So when we look at the something inside here, so it's hard to see. Let me just do another one. We see that these two are all vectors. And because it's 0, so both of these two are not there. And let's go into it. The first iteration ended, and the second iteration at this time, when we are trying to access the index 1 of a vector with size 1, we fail. We are accessing something out of bounds. Anyone knows how to fix it? Yeah. Where? In the loop? We're putting what in the loop? Line 58 in the loop. Yeah, that works. But in this case, the vector will need to be resized every time. So it's not as efficient as doing a single resize here. But both of those would work. So if we just resize this to be number of intersections, then we don't need this line anymore. But your fix also worked. And let's remove this, stop the debugger, and let's do the release mode. Always remember to also change the launch target. Build. And run. Passed. One test passed. And let's also do the same thing to the performance test. 297 exercise 1. Debug tester perf. Enter. Okay, this terminal is changed to another terminal. Okay, this one. Do this and go to the tests, and you will see that the test file changed to the performance test file. I'm just going to do it again. Find 3 segments of intersection. This is the test that we want to keep, and we want to remove the other ones, which is directly connected. This is in a text fixture, directly connected, and let's just remove this. Yes, remove this and save and compile the unit test release. And launch target is in build release test. Build and run. You see that one test passed. So this is just useful technique for you to use. Any questions till this point? Let's just revert this error and let's use the other approach that's here. To run Valgrind, use the following command. Let's change the unit test debug and the debug target. We want to save this command. So this command is given to you so that you don't need to write it anymore or memorize anything anymore. I'll compile it and I'll paste the command. And this will run Valgrind for you. So whether you use Valgrind or the debugger depends on your own. So you think which one is easier, then you use whichever one. Because the Valgrind will detect all of the memory failures for you, so it will have a really long runtime and a really long log. Let's wait for it to run and see. So it has a really long log. Let me remove the other 2 files because they appeared at the end. because we want to eliminate the length of the file directly connected and the find angle between segments. Remove that and build. So just notice I'm building in debug mode and run the Valgrind again. This will only give you the memory problems in the function that we are interested in. So depending on the bug and depending on you, which approach you want to use, it doesn't matter. You may find someone is easier than the others. Or you can try all of them if you can't find the exact bug location from the first try. The problem with Valgrind is that it doesn't stop at where the first error occurs, so you have to scroll way above to see the actual log. And it's too long that I see the console. So adding this means that I'm redirecting all of the logs into this file, valgrind.log. And let's wait for it to finish. So this character alone will redirect the output of your program. And adding this n% will redirect everything, including all of the error messages or all of the outputs from Valgrind. Just a useful technique for you. And let's look at the valgrind.log file. So the first error is here, invalid read of 8. It sets that at vector int pushback and load intersection 3 segments m1.cpp65, which is here. So it tells you the same thing as the debugger. And in some cases, you may want to also look at other things, like after this, it says address. So this address that you're trying to access is 8 bytes after a block of size allocated at this address, where this is allocated at load intersection street segments m1.cpp58, which is here. So this actually tells you more than the debugger. It tells you that the vector that you are trying to access is right behind a vector that you allocated here, which will give you a hint that the crash was because you did not allocate the rest of the vectors. Okay. Does that make sense? And I hope all of these tools will help you in your milestone. And yeah, that's all I want to show you for this demo. But just remember the command that I used to get the tester code out is the debug tester command. Which is not here, but here in this one. So instead of run tester, I'm using debug tester and the tester name. And this specific bug itself is about memory. For other bugs you may want to look at, they may not be about memory, but about the actual values. Maybe it's assigned the wrong value at some point. So it's going to be the same approach. You get use the debug tester to get the actual test that's failing, and you go to the actual test code. So if it's passing part of these, because these ones are checking that is the expected value equal to the actual value that you are outputting. So you can go to whichever one is failing and set a breakpoint here and do the debugger again, so that you can trace through the entire program flow and see what's going wrong at which point. So it can be a really useful technique to use for your milestone 1. So if you have any questions, this is the time to ask on debugging. If you don't have any questions, we'll have a break for about 10 minutes. Let's get back at 4:02 and we'll start the last team debugging activity. Yeah. Okay, let's get back and let's do the last team debugging activity. So the code that's going to be given to you is about sorting the arguments like this. So the program name will be argsort, and on the command line, you will be given some numbers, and your output will be the sorted version of the numbers in a list. And this will be the code that's given to you. So to get the command line arguments, you have argc, which is the number of command line arguments, and argv, which are the actual arguments themselves. And this is in an array of character pointers. And you will have your main code here and the sort code here, which I'm not going to go in detail. You will be able to need to find them yourself. And what you will have in your argc is the number of arguments. And the first argument is always going to be the program name itself. Then you will have in forms of characters or character arrays each of the numbers that you will need to work with, and output will be the sorted list of the numbers. like this. And next, I would like to ask you to go to this URL, and you will have the code in the web-based IDE, and this IDE will have a debugger in it. And let's use what we have talked about in this tutorial and find all of the bugs. There will be multiple bugs. And let me know if you can open it. Can everyone open it? So you will see something like this. You have the sorter function and the main function. And the command line inputs are listed here. And if you try to run it, it will compile and run the program for you. I'll give you a few minutes to work on it. Okay, we found the first bug. We're not outputting anything. We're not outputting anything because we are not inserting anything into the vec. And how did you find it? So you look at the code. Yeah. So you see that there's no output. So you look at the vec, which is being outputted, and you see that nothing is inserting into it. And let's fix that by adding this pushback command here. And let's run it again. So now we are seeing output 016. But we're giving in 613. So we should be seeing 136. So we have other bugs. What are the other bugs? Try finding them. Staring at the code correctly is the least productive thing to do. Any ideas? Yep. So you changed I equals to 1 and deleted the -1 here. And why? Yes. So the very first argument in argv is the program name, which is not a number. So when you're trying to inputting it into an integer using this operation, it's going to read a 0. And it's not reading the very last one because of the -1. Yes. And that is all of the bugs. So let's get back here. What approaches did you use? Did you just use? Did you need to carefully read all of the code? No. Because you just need to understand the bug and try to fix it. So which of these three have you used? So you set a breakpoint and you just step through. So you step through. And this lies partly in Wolfen's and the infection model, because you start from the beginning of the main and you try to eliminate the ones that you're sure that is correct, and until you see the actual bug. And to fix the first bug of not pushing into the vector, you also use hypothesis testing, because you looked at the bug and you made a hypothesis that maybe this vector is empty, and you tested it until you fix the bug. Yeah. So these are just more resources on debugging, and that's it for today's tutorial. I hope you enjoyed it. I hope you learned from it. And if you have any questions, feel free. So yeah, just emphasizing that blankly staring at the code is the least effective way of debugging. You have to first start from a bug, then you work back through all of the possible causes for the bug, eliminating some of them, testing some of them, until you actually find the bug and fix it. So the debugging techniques that I just showed today may not be entirely useful for all of you,